Hey, ladies and gentlemen, welcome to 3.6. It's on our fit align to data. And so this is identifying and using lines of best fit. But first, before we can do that, we need to talk about correlation. So go ahead and pause the video here so you can write that down. Correlation is a statistical measure that expresses the extent to which two variables are linear related. And so it goes from -1 to +1. So what that means is if I have two variables and we're talking about relating them to each other, such as maybe your height and your age, okay? And we'll see that those are going to be a positive correlation. As you get older, you get taller to a certain point, okay? And so it's going to be positive. So it's going to have like that look of like a positive slope. Okay, these would be examples of strong positive, weak positive. Okay, a strong negative, maybe that's going to be value of your car from when you buy it until when you're done with it. Okay, as you buy your car and you use your car, it's going to have negative correlation. The price is going to go down as the age increases. And then here's another example. That one's a weak, or I mean a moderate negative. This one's a weak negative. Strong, moderate, and weak is all dependent on how tightly close those points are to their line of best fit. And we'll talk about that in a moment. But it goes from -1 to +1. So if it's got a -1, that's going to be like a really strong correlation, negative. Okay, so that's going to be close to -1. Okay, a strong positive would be close to +1. The closer it is to 1 or -1, the closer it is to being just a straight line. The closer it is to 0 is going to be the farther away the points are going to be. Such you still see down here we have this one that's none. This one has no correlation. Oops, no correlation. Those would be things like your shoe size and how many blades of grass you have in your yard. Okay, those have no correlation. It's going to be scattered all amongst. All right, then let's talk about line of best fit. Sometimes it's called line of fit, prediction equation, regression equation. Those are all the same types of verbiage for this line that's drawn in amongst our data points. So if you need to, go ahead and pause the video here to write this down. But it says a line on a graph that shows the general direction that a group of points seem to follow. And so that's going to be the line that like best fits the data. It goes in the same general direction of the data. Now there's mathematical actual like computation for this, and what it does is it minimizes the distance between the data and its line. So if you look here, these all they'd average that distance out. Now when we say line of best fit, we don't want to say we draw that line. That doesn't best fit this data. If I erase that and I draw you something more like this, that one fits the data better, but not as good as the black line that's already there, because you'll notice some of these lines are way far away from that line, and you want to do your best for it. So we're going to practice here on some lines, but first let's look at a couple lines that are already in the data. This one's going to show a negative correlation because it is going negative slope. Now we do have some points here that are really far out, but this line is going to best fit this data. Now, some people, if you drew these out by hand, you might have a little bit more of a slope to it, and that's okay. When we're drawing them out, you and I and your neighbor might have something a little different from each other. Here's another example, arm span versus height. This one has a positive correlation. So here we see our slope here, and then we have a y-intercept. Okay, so that's a really nice correlation there. Let's look at, we got some examples here, and we're going to draw our lines of best fit. All right, so this one's the size in carats. Maybe it's a gemstone, I'm going to guess, because that's what that carat stands for, and the price. So you see, as your carats get larger in your gemstone, the cost increases. So this gives us a positive. This is a pretty strong positive correlation. Now go ahead and take a straight edge. That's the big thing. You want to have a straight edge. So I'm actually going to switch over to my line. I'm going to change the color. Let's go red. All right, so we want to draw our line of correlation to fit. Now my general rule is kind of looking at my data points. I kind of want to have about half of them above and half of them below. So you may look at this and go, ooh, I would adjust the line down a little bit, or maybe I adjust the line up a little bit, and that's fine. Okay, like I said, each of ours are going to be ever so slightly different. All right, here, score on a final exam versus hours spent studying. Generally, there's a positive correlation to that. The more hours you spend studying, the better you're going to do on an exam. Okay, so go ahead and take a straight edge and try and draw a line of best fit in here for me. Something kind of through there. Now notice, sometimes my line goes through some of my data points. Sometimes it doesn't, and that's okay. All right, here we see some negative correlation. I don't even have labels on this graph. So imagine what you would, that as one thing increases, the other thing decreases. Okay, so if we draw a line of best fit for this, I'm just gonna give it a shot and then I'll adjust it as I see fit. Actually, I don't think that one's too bad. Okay, so just again, your goal is to fit your data the best you feel. Maybe you'd want to move it down ever so slightly. You know, you can kind of be a little bit different from each other. And then we have the last one here, age and accidents, and this could be silly things such as tripping up the stairs, or maybe it's more severe accidents. But there's no correlation here for this one, so we don't have a line of best fit. We just can't. Some people might say, oh, your line of best fit might go this way, but you got some really big data points out there. Maybe they think the line goes this way. Really, neither of those is a great fit for this. So what we actually are going to do is we are going to have our calculator do this. Now we can do this out by hand. What you would do is find 2 points, you'd find the slope, you'd plug it in point slope, and you'd convert it into like slope intercept form. Now that way we've been practicing for this unit, but I'm going to show you how to do a line of best fit or a regression equation on our calculator. So for that, I'm going to just jump over to my computer to pull up my calculator. So you're going to need your graphing calculator out. This is for a TI 83 or an 84. Whoop. Both of those are fine. They follow the exact same rules. So if I pull my calculator up, so first it says press stat and press a 1 and enter your data. I'm going to slide that over here. So I'm already there. I'll go out. So stat and edit, so that's 1. This is where we enter our data. We put our X values in list 1 and our Y values in list 2. Now look at the top. If you're missing L1 or L2, just talk to me, and we can reset your computer or calculator, and then we can get list 1 and list 2 back in. All right, so once you have data entered in there, then we go to our stats and we go over to statistics. To access the statistics menu, that's under our calc menu. Okay, so in there, you'll see number 4 says linreg. That stands for linear regression, and it says ax plus b. That's the form we've been working with, is slope intercept, mx plus b. Here they call it ax plus b. So you can push number 4, or you could arrow down to 4. You want to make sure that it says list 1 and list 2. Now, if you have an older version of calculator, like an 83 plus, it might just automatically assume list 1, list 2, and take you to your main screen. So arrow down to calculate, and then we'd hit enter. I don't have data in there, we will shortly. And then that's what we would do. All right. So this is what yours would look like on your home screen. If you have an older calculator, it might automatically go to that. Then we have graphing that linear regression on our scatter plot, and we can look at that a little bit later. Let's jump to our next problem. Oh, come on. We'll go there. All right, so I know in your notes that that table didn't show up when we printed it. So take a pause here and write that table into that open space in your notes. So it says, make a scatter plot of this data. Okay, so when you do this, here's what I'm going to suggest. We're going to put hours studied on the bottom. And then on the side, we're going to write our score. Now, obviously, because it starts at 1 and it goes up to 12, we don't have 12 across. So we're just going to count out by twos. 2, 4, 6, 8, 10, 12, 14. And then for score, we're going to put a jump in our graph. So a little like zigzag there. And then that line is going to start at 70. And I'm going to go up by 5. So 75, 80, 85, 90, 95, 100. All right, so we're going to go ahead and graph these. Now, not all of them are going to be nice and on actual lines, and that's okay. So 5 hours studied has a score of 80. So we're going to go between the 4 and 6 and all the way up to 80. 9 hours had a score of 95. So between the 8 and 10, up at 95. 3 hours had a 75. So between 2 and 4, we're up at 75. 12 hours has 98, so almost to 100. And then 1 was at 70. So 1 is at 70, right about there. So we have our scatter plot for this. We are going to actually have our calculator find our linear regression. So our slope, our y-intercept. So I'm going to just a sec. All right, so we're going to pull up our calculator and we're going to go into that stat button and we want to put the data in. So like I said, hopefully you wrote it down. So enter. And in my list one is my axis. So I'm going to put hour study. So that was a 5, 9, 3, 12, and 1. Then you're going to arrow over into list 2. And we have to put the coordinating scores in with it. So for 5 hours, they earned 80. 9 hours got a 95. 3 hours got a 75. 12 hours had a 98. And 1 hour had a 70. So those match. Then our next direction was to hit the stat button, the statistics button, and arrow over to calc. Number 4, you can arrow down or press it. List 1, list 2, and calculate. So this is what ours looks like. We should all have exactly the same. If you don't have exactly the same, it means that you didn't enter something right in on your calculator. So go back to your lists and make sure that the list 1 and list 2 are exactly the same. So now we can write these in on our form. So A is our slope, so 2.725. Y-intercept was 67.25. And then it's our equation for regression line. So now we're just going to plug our slope and our y-intercept into slope-intercept form. So y equals 2.725x plus 67.25. That's our linear regression. Now, because those decimals were so short, I can write them all out. Some of the decimals will be really long. Pay attention to the directions on your exercises because they'll tell you like rounded 2 decimal places, 3, because how we round it can make our answer that we use for predicting very different. So just make sure you're watching directions there. All right, so that says predict what score a student who studied 10 hours for the exam would receive. So 10 hours, hours was our x value. So we're going to take our equation and we're going to plug 10 in for our x value. All right, so go ahead and grab your calculator and type that in to estimate what score somebody who studied for 10 hours would receive. Okay, hopefully you got that done. And we find that their estimated score would be around 94.5. All right, there you go, ladies and gentlemen. Thanks for hanging in there with me.